Hi, and welcome to Yellowstone National Park. The park sits on top of one of the world's largest active volcanoes, a supervolcano. This accounts for the park's unique geographic landscape, as we will explore in today's virtual field trip. The first stop on our field trip will be the Grand Prismatic Hot Springs, where we will learn about a unique community of Yellowstone's biosphere. Grand Prismatic Hot Springs is located in a hydrothermal basin. It is the park's largest hot spring and one of the Earth's most colorful natural features. As you can see, circling the perimeter of the hot spring is a bright spectrum of different colors. These bright colors are actually communities of tiny microscopic organisms known as thermophiles. Different kinds of thermophiles are adapted to specific water temperatures. And so the colors that we see also represent different water temperatures. Because these little guys thrive in extreme conditions, they capture the attention of microbiologists. It is hypothesized that these thermophilic microbes are descendants of the earliest microorganisms to evolve on our planet. Scientists study these organisms to unearth more information about how ecology and geological processes work together to influence biological evolution. The next stop on our journey is the Obsidian Cliffs, where we will discuss a unique feature of Yellowstone's lithosphere. As you probably guessed from the name, these impressive cliffs are made from obsidian. Obsidian is an extrusive igneous rock that was made by the rapid cooling of silica-rich molten lava from volcanic activity. These cliffs were formed approximately 180,000 years ago from rhyolite lava flow extruded from the Earth's crust. They have a thickness of about 98 feet, and they tower approximately 200 feet over the Obsidian Creek down below. They are at an elevation of 7,400 feet above sea level. Archaeologists have uncovered evidence of early human activity in this region. The glassy volcanic glass was quarried from these cliffs 11,000 years ago from early hunter-gatherers. The next stop of our journey will be the electric peak of the Gallatin mountain range. It is the highest point of the Gallatin mountain range, and like other features of Yellowstone's terrain, the mountain range was formed from volcanic activity. At an elevation of 11,000 feet, we will take a look at some of Yellowstone's atmospheric phenomenon. Because of its sweeping views, Electric Peak is a popular hiking attraction. Due to the peak's high elevation, the mountains are prone to afternoon thunderstorms, especially in the summer. Lightning is a common occurrence associated with these thunderstorms, and it poses the greatest risk to hikers. As warm, moist air moves over the peak, it is pushed upwards through orographic lifting by the steep elevation. The strong updraft forces air to cool quickly, creating cumulonimbus clouds just over the peak. Within the cumulonimbus cloud, there is a buildup of electrical energy. The polarity between the negative charges within the cumulonimbus cloud and the positive charge of the rock of the mountain cause lightning to strike the peak. In fact, it is this electricity which is how the peak received its name. During a geographic land survey in 1872, a team of geographers approached the peak while a thunderstorm was also drawing near. The team began to feel tingling and sensation in their extremities and their head, and they also heard the crackling in the rocks. They could literally hear and feel the electricity, which is how the peak got its name. The next stop of our field trip, we will wrap up our journey with a cute little phenomenon associated with Yellowstone's hydrosphere, the mud pots. Mud pots can be found in and around Yellowstone's thermal areas. They are formed when the standing surface water of a hydrothermal feature is so acidic that it dissolves the surrounding rock into liquid clay, also known as mud. When hot gas or water vapor is pushed up through the mud because of volcanic activity, we see bubbles at the mud's surface. The gas which rises through the mud is mostly hydrogen sulfide, which gives these mud pots their distinctive odor of rotten eggs. The mud usually begins a creamy white color, but over time, iron oxide tints the mud different shades, including orange, gray, brown, and even pink. Because of their peculiarity, the mud pots are a favorite visit among artists and photographers. And that concludes today's virtual field trip of Yellowstone National Park.